Hello and welcome to Ty Teaches Math. In this video, we are going to be covering solving systems of linear equations. And in this video, we're actually going to be talking about just solving it graphing, okay? Now, there's a couple of different ways of solving systems of linear equations. There's doing it graphically, and there's also doing it algebraically. We're going to be focused on the graphically portion, okay? Now, a system really isn't all that complicated. It sounds way more complicated than it is. All it is two or more equations, okay? And in this particular video, it's going to be two linear equations. There could be systems of 3, 4, 5, and so on, okay? So this is a system of linear equations, okay? And what's neat about a solution to a system is it's actually the point or points where these lines intersect one another, okay? So that's why we're going to be solving it graphing, okay? So to graph them, we just graph these equations like we would any other linear equations. So I'm going to go ahead and graph this top one right here. This top one has let me change the color here. This top one has a slope of negative 2/3, which remember means it's going down 2 and right 3, and it has a y-intercept of 2, which is a point 0, 2. So I'm going to go ahead and graph this now. So 0, 2, slope of negative 2/3, so down 2, right 3, down 2, right 3, down to right 3, okay? And now I'm going to go backwards by going up to left 3, up to left 3, up to left 3, okay? And now I'm going to go ahead and connect it. So there's our first line. That's our first equation from the system graphed, okay? So there is our equation. Now, when we're solving systems by graphing, I recommend plotting as many points as you possibly can. I know you really only need like 2 to 4 points to make it somewhat accurate, but try to graph as many points as you possibly can to make it as accurate as possible. Okay, so that is our first equation here graphed. Now the second one, I need to first get this in slope-intercept form. So I'm just going to divide each side by 2. And what that's going to become is y is equal to x plus 7. So I would go ahead and divide each side by 2, and that's how I get y is equal to x plus 7. So now I can plot that. The slope here is 1. That's 1x, okay? So the slope is just 1, or up 1, right 1, up 1, right 1. And the y-intercept is 7, okay? So I'm going to go ahead and plot that. And now I'm going to use the slope. Up 1, right 1, up 1, right 1, up 1, right 1, and now I'm going to go down 1, left 1, down 1, left 1, down 1, left 1. And I'm just going to keep going, but you should already kind of notice something here. What you should notice is that these two lines had the exact same point. If I connect these, notice that this point right here is where they intersected one another. So that's actually what the solution to the system is. Remember, all the points on a line are solutions to that equation. So it should make sense that the point in which both lines intersect one another is a solution to the system, because that point is a solution for both equations, or 3 or 4 equations, depending on how big the system is. Okay, so since they intersect at this point, that means that point's a solution. That means our answer isn't just going to be like x equals 2 or r equals negative 8, okay? Our solutions are always going to be an ordered pair for a system, okay, of 2 equations and 2 variables. So our solution would be the point. It's right here, negative 3, positive 4. So we are going to write our answer as that point, negative 3, negative 4. And that's how your solutions for systems should always be written, as a point, okay? So you can't write just x equals negative 3, y equals positive 4. Write it as a point. All right, let's take a look at another example or two. Okay, so we have another example here. We have a new system. We have y is equal to 3x minus 4, and negative 4y is equal to negative 12x plus, let's make that a nicer number. Let's make that plus 4. Yeah, that works out. Now, what we want to do is graph both of these lines. So notice I'm using different colors. You don't have to. I'm just doing it to make it a little bit easier to see. And I mean, you could do it. It makes it nice. It makes it a little bit easier to read, so feel free to if you want. If not, just use the same color. It doesn't matter. Okay, so this first equation here has a slope of 3 and a y-intercept of -4. So I'm going to go ahead and graph that. So y-intercept of -4, slope of 3. So up 3, right 1, up 3, there I am, right 1, and then so on and so on and so on. And remember, you do want to plot as many points as you possibly can, just to make it as accurate as possible. And now I'm going to go ahead and connect these with a solid line. Okay, there is our one line. Let me extend this a little bit. All right, so there's our one line. Now the other one we have to get in slope-intercept form. So I'm going to divide each side by -4. So what that line or that equation is going to become is y is equal to 3x minus 1. So this has a slope of 3 and a y-intercept of -1. So I'm going to go ahead and plot that. So -1 is the y-intercept, up 3, right 1, up 3, right 1, up 3, right 1, and so on and so on. And then I'm going to go down 3, left 1, down 3, left 1, down 3, left 1. So here is our other line. Trying to make it as nice as possible. So there's our other line. So remember, a solution to a system is where the lines intersect, the point or points in which they intersect. And what you're noticing here is a pair of parallel lines. So notice here, the slope for both of these is the same, but the y-intercept is different. That means they're parallel lines. And you should remember from geometry that parallel lines will never intersect. So if the solution to a system is a point or points at which they intersect, and these are parallel lines which never intersect, what that means is that there is no solution. So this is actually a special case, okay? That's a special case. If you ever have a pair of parallel lines in a system, just know that they're never going to intersect. So it's always going to be no solution. If you recognize that by looking at these slopes and going, well, those are the same, but these are different, that means they're parallel, no solution. Feel free to do that right away, or you can kind of see it visually. Notice that these are never going to intersect one another. I wanted to show you that example just so you can get an idea of what is happening here. Now, another special case is let's say that they were actually the same line. Let's say that both of them had a y-intercept of -4, which means you'd be plotting the same line on top of one another, okay? That's another special case, and what that would be is infinitely many solutions, because every single point on those lines are overlapping and intersecting with one another, which means it's an infinite number of points, so an infinite number of solutions, so infinitely many solutions. So most of the time, the overwhelming majority of the time, you will have one solution, and that's really the only possibilities. You can have no solution, you have a pair of parallel lines. You have one solution, you have lines that intersect once, or you have the same line on top of one another, infinitely many solutions. So those are the only three possibilities, okay? I did want to point those out to you, but let's take a look at one more problem, and I'm going to make this one a little bit more challenging in the sense that neither of them are going to be in slope-intercept form to begin with. Okay, so we have a new example here, and notice both of these are not in slope-intercept form, so we're going to have to get them in slope-intercept form. So if you want to do that now, go ahead, pause the video, feel free to do that. If not, I'm going to quickly run through it, and I do also recommend that you have graphing calculators handy if you have one, because I'm going to show you guys how we can use that to help solve these or double check our answers as well. So I'm going to go ahead and get this in slope-intercept form. The first thing I would have to do is subtract 4x from each side, so this would now become -2y is equal to -4x minus 16, okay? And the next thing I would have to do is divide each side by -2. So when I divide each side by -2, this is going to become y is equal to 2x plus 8. So that tells us that the slope is 2 and the y-intercept is 8. So I'm going to plot that one. So up to right 1, and notice I'm already out of room there, so I'm going to go backwards. So down to left 1, down to left 1, and just keep doing that until you run out of room. Okay. There I am. All right. So there we go. And here is our line. About as good as I can get it. Okay, so that is our first line. Now our second line, that should have been here, but whatever. Now our second line, once again, need to get this in slope intercept form. So I'm going to add 3x to each side first to get 4y is equal to 3x plus 12, and now I'm going to divide each side by 4, so this is going to become y is equal to, now 3 doesn't go into it perfectly. For the love of God, do not make that a decimal, do not make that 0.75x. How are you going to graph that? Keep it as the fraction 3 over 4, okay, so 3/4 x. If you can reduce that fraction, if it was like 6 over 12, obviously make that 1/2, but don't, for the love of God, do not make that a decimal. Keep it as a fraction. It actually helps. Fractions are numbers. Don't treat them poorly. Okay, so 3/4 x plus, now 12 does, or 4 does go into 12, so plus 3. So our slope is going to be 3/4. Okay, so up 3, right 4, and our y-intercept is 3. So I'm going to plot that. So plot 0, 3, and now I'm going to go up 3. Where am I at? Oh, here we are. Right 4. Up 3, right 4, and there we are. Okay, and notice I'm definitely not going to get the solution on this side, so I got to go backwards. So down 3, left 4. Notice that's where it is. If we want to keep going, we can, but notice we have the solution right there. If I connect these, notice, boom, my solution is right there. So our solution is going to be the point -4, 0. Remember, the solution is a point, so write it as 1, okay? -4, 0 is our solution. Okay, so now I'm going to go ahead and show you guys how we can use the calculator to double check our answers. So you should have a calculator similar to this one here. Okay, I'm going to turn it on, go to y equals, and I need to graph both of these in slope intercept form. So make sure you have the 2x plus 8 and 3/4 x plus 3. Put the fraction in parentheses, 3 divided by 4 in parentheses, then x plus 3. Okay, I'm going to click graph, and notice this is what we would get. Now, it's a little difficult sometimes to see exactly where that solution is, so we could use something called the Intersect Tool that is in our calculator. So we click on second and trace, and now notice number 5 is the intersect, so I'm going to go down to that, click enter, and now it's going to say first curve, okay? So I'm going to use, now notice we're on this line right here. I want to scroll to where that solution, or where that intersection is, as close as I possibly can. So right around there looks good. I'm going to click enter. Now it's going to say second curve, question mark. It's like, hey, where should it be? You already should be over it, but if not, just make sure you get back over it and click enter again. And now it's going to be like, guess? It wants to know if you want it to guess. Click yeah, so click enter, and boom, there's our intersection. -4 for x, 0 for y. So notice it gets us what that solution is, okay? So that's how we can verify with our calculator if the solution is correct or not, okay? Now, if the solution was something like 10, 30, you're going to need to change your window a little bit. Notice how this only goes from -10 to 10. So you would need to change your window a little bit, but that's how we can use our calculator to double check our answers. So let me go ahead and minimize that now. Okay. Boom. All right, so that is solving systems of linear equations graphically, okay? Now, we are also going to be talking about solving them algebraically. Just know you can use that calculator trick the exact same way to double check those answers as well, because we're still finding the exact same thing. I hope this video was helpful. If you have any questions, please feel free to let me know. And in the next video, we're going to be solving systems algebraically. I look forward to seeing you in that next video.